What's up, amigos? Today we're looking at the aerodynamics of a NACA 0012 airfoil at 9 degrees at a Reynolds number of 6 million. So this is in our series of NACA or airfoils in general. You can find in the link here. And first of all, we can see that there's quite a lot of pressure at the leading edge. And this is obviously different to the other airfoils at low angles of attack because there's a lot more low pressure. And also there's a bit more high pressure underneath. And that creates the lift that we're looking at. And you can see that just from this picture here, if you look at the pressure distribution, you can get a good idea as to where the lift is being produced. It's really at the front here. And this is an orbit around the airfoil with the pressure plotted onto the surface, ranging from minus 3,500 to 3,500 pascals gauge. And this gives you a good idea as to what the extent of the low pressure is. So you can see at the front, there's a lot of low pressure, and then it gradually declines to gauge or a bit above gauge at the trailing edge. Underneath, on the other hand, you don't really have much of a change in pressure after like 15-20% of the chord. It all stays fairly consistent. It's really just the front bit that's producing that very high pressure, which obviously contributes to lift. And a little bit to drag because it's not directly in the lift direction. And this is the velocity distribution over this plane that's dissecting the wing, the airfoil. And again, the top surface, which is the suction surface, you get a very high velocity because the flow is accelerating a lot more than any of the other low angles of attack. Interestingly, now you can start to see a bit of a wake to this wing. So obviously the fluid is getting a lot of energy extracted out of it effectively in the form of lift, and then there's also drag being produced. And that you can see in the wake that it's growing, so the pressure drag is going to be increasing as it does. And this is the velocity distribution over the surface of the wing. And you can see that there's really just the front part of the wing that there's a lot of exciting stuff going on, like it's obviously high pressure at the front. Now, the velocity of the free stream is 90 meters per second. And it's interesting that the trailing edge is actually very close to 0 meters per second. So let me expand this more so we get the legend in. And so you can see it should be like color. So obviously that's due to the wake. And likewise at the front, on the pressure side, we have very low velocity, but that's not due to wake, that's just due to the stagnation line. Videos in the playlist that I mentioned earlier, and check out the Atmosphere Hawk, get one of those to make your experiments more accurate. Peace out, amigos.